Our university is called University of Lorraine or Lorraine University. So it is in the top 10 of the university in France. So we are close the border with, as we are in Lorraine, we are close the border with Germany or with Belgium, with Luxembourg. So two main cities of this university are Metz and Nancy. So this is a big university because we have more than 60,000 students, 1,800 PhD students, and that the university is covering something like 10 scientific area, and in which it is associated, of course, the education area. This scientific area is composed of about 60 laboratories, and belong these 60 laboratories, one domain which is well known for this university is the domain about computer science, automation and control. And within this domain, so we have two main labs, which are called the CRAN and the LORIA. CRAN for Nancy Research Center for Automatic Control, and LORIA for Lorraine Research Laboratory in Computer Science and in its application. These two laboratories are affiliated to the CNRS in France. So the CNRS in France is a National Center for Research, for Scientific Research, which is a very important entity in France. And these two labs are the main items, the main entity for this implication, this involvement of the university in the project, because these two labs are complementary skills. CRAN is mainly about manufacturing, and LORIA is mainly about artificial intelligence and ethics. So the first one is mainly about coordination on the project. The second one is mainly about scientific contribution in work package. And the last one is mainly to promote what we call ethic by design approaches. So if I go back to the first one, so about coordination, we support administrative aspect, management aspect, in order that the project is running one. The second aspect about coordination is we try to offer IT infrastructure and all the tools necessary that for making collaboration between the different partners of the consortiums. So, for example, we offering Teams frames in order that to support the exchange and also the possibility to store the file, etc. And the last aspect about coordination is also we try to ensure a scientific consistency within the project in terms of the result obtained. So about the second activity, which is more contribution. So of course that as we are labs, so we are working on the project in two main topics. So one topic is about predictive maintenance, mainly on prognostics consideration, and the second one, which is also, of course, on maintenance area, is about optimization of the maintenance plant. So for these two topics, we already have two PhD students working on these two topics. So for the prognostic consideration, it is mainly that to try to use deep learning techniques that to support the prognostics about some components. So in that way, we are mainly involved in the use cases that are related to continental end users. So of course that prognostic is very useful that to try to predict what is happening on the system, in which way that so the system is going on, and if we want to avoid some bad situation about safety, about quality of the product, about, of course, degradation on some components. So it is this first aspect. The second contribution is about mainly maintenance optimization. So it means how we can use artificial intelligence techniques, mainly reinforcement learning, that to try to find some new way about, some innovative way about that to try to optimize the maintenance plan. So because it is more difficult if we want to integrate all the parameters from the use case and to take into account, of course, not only, for example, the spare part consideration, but also the degradation of the components, the availability of the people in order to develop the maintenance plans. So the last activity, which is also very important for the European Commission, is we try to promote ethics by design. So several people in the area are well-known guide about ethics, but this new consideration, which is called ethics by design, try to in contradictory with what are the current, the usual ethics guidelines, that to promote now the way that we have to speak ethics all along the project and to consider ethics at the specification phase, then to impact the development phase, etc. So it is also a very innovative aspect of the project, which is to promote some very new approach for ethics. We expect a lot of things because as we are a university that and as we are coordinator of the project, we would like to try to take benefits of the project in several areas. Of course, the first one is to enrich our experience about the coordination of the project, because this project is, of course, very important, 10 partners. So we need also to be very clear about the administrative, as I already said to you, but also something about IT problems and, of course, scientific one. So it is the first aspect, first interest for us to be inside. So the second one is clear, is that we are also academic guide, is to promote our research with the different members of the consortiums and to take benefits from the end user, for example, consideration that will improve also our research by making confrontation about what we try to propose as a scientific contribution to know exactly how this scientific contribution is also interesting for industrial world. From the result of this scientific work, one other interest for us about the project is to develop some publication, because publication is also a very important aspect, both for the project inside in terms of dissemination, but also for our own activities as a researcher. So another one is we have the opportunity within the project to reinforce the collaboration we have between the CRAN and the laureate. So it's very important at the internal aspect for us, but also that now more for external collaboration. Our interest is also that we extend our network by considering that what it is bringing by the different members, so the different partners, in the way that we have the possibility to enlarge our collaboration, our existing collaboration. We already work, for example, before with some people like Techniker, but never with people like ATC, etc. So it's very interesting for us that to be inside. And my two last point will be also, as we are academic guide, one part of our job is to try to transfer what we are doing from research and innovation towards the education world, because we are also teacher. So if we want to promote some AI result within the project, we have also, of course, to try to transfer this result towards the education world. And we have one master now in which we try that to consider some AI purpose in some lectures. And my last system will be that because it is also a very strategic aspect about University de Lorraine, is that to reinforce the presence of this university in Europe on the topic that we are very attracted with. If we go back to not necessarily at the beginning of the project, but before that, so the presence of data is now, as we are working about Industry 4.0 or digital world. So now data is a very important aspect in manufacturing. So before it was more the physical aspect, the component and the process, but now data is also a very useful item that we have to be considered. So that in manufacturing, we have a lot of data now because we have a lot of sensors. The sensors are new technology. So the main question is how we can use this data for helping that what is happening in manufacturing in terms of monitoring of the manufacturing system, decision in the manufacturing system. So in that way, artificial intelligence can propose some techniques that they can be useful for processing the data, but not processing for processing, but really processing for aiding to take, for example, some decision at the right time in the right place by the operator. So this is my first consideration about AI in manufacturing. The second one is also that we have the possibility, as we want to keep human in the loop in the manufacturing, because we need to have human also about the employability of the people, etc. So artificial intelligence can be not the opportunity to replace the human, but really to give some added value to the human that to help him to take the right decision, as I already said. So artificial intelligence can provide some result that can help the human to take the best decision. So another item that is very important also by using artificial intelligence is that in manufacturing, we have now a lot of complex systems. We have cyber-physical production systems, cyber-physical social system that we have human, we have a component, we have a line, etc. And face this complexity, artificial intelligence could be a way that to create some model by learning, for example, without knowing exactly how all the manufacturing complex system is running. It means that the model could be created from the data, from the evolution of the data, and not necessarily from all the knowledge about the system. We cannot, for some complexity, create some deterministic model. We need really to use the data and to create some model from this interdependency between the data. We can bring really an added value for AI in manufacturing. So because first, what it is well known in AI, it is the use of AI in computer science. And you have in computer science some systems, but what it is not taken into account in this area is that as in manufacturing, a manufacturing system has a dynamics. We have, of course, the evolution all the time. We have a lot of factors impacting the evolution of these systems. We have not necessarily the presence of very relevant data. It means that we can have, I don't know, 10 million of data, but these 10 million of data are only representative of nominal situation and not necessarily like fail situation. So in the project, what is interesting is we have end users. So we have use cases. So these use cases are really representative about the complexity about one manufacturing system. So if we want, because our scope in our project is to develop algorithms, is to develop models, is to develop approaches, is really that to be sure that these approaches, these models could be an added value in manufacturing. And so the frame proposed by our project should be in the right way that to have a first answer to how we can implement AI in manufacturing and what is the benefits of AI in manufacturing. In that way, by the use cases, we can try to support the scalability in manufacturing, which is very important that we can have AI algorithm, that it is well running for a computer science application, but absolutely not when we go to the scalability of a manufacturing system. Also that in some of our use cases in Continental or in EOS, we have also some problem of safety because we have some human working with the systems, and it's impossible that we give all the decision to artificial intelligence techniques. So our project should also try to give some answer, to give some contribution to how artificial intelligence could also good techniques in the frame of manufacturing for supporting safety. Also that in our project, what is one aspect that we have to take into account for AI that we don't find in computer science, it's the fact that the manufacturing system should keep competitivity performances. So it's not possible to produce one product without the fact that we have then to sell the product. So that we have to be sure that what will be implemented in our project will be a way to converge to our performances. And so we can bring also added value benefits to know exactly, okay, we propose algorithm, we propose models, and one contribution we want to support is the fact that this model, this algorithm supported by artificial intelligence techniques will be able also to propose some conversions to our performances. And the last aspect for me, it's also about what we promote on the project is a symbiosis between ethics and, of course, consideration, which are more that we want to improve algorithm, we want to improve the process, so process control. But we would like that to be sure that during all the project that we have in mind that by implementing ethics by design, perhaps we will impose to reconsider some aspect of what we try to develop, and in that way it could be also very important for the community that to receive this information that by implementing in manufacturing artificial intelligence, it is also necessary to take this type of consideration into account in the way that the result we propose, so algorithm proposed, will be well used by the human inside.